All right, good morning, Precalculus A3. This is April 23rd. Hopefully everybody's having a great start to your day. We had just a little bit of an introduction just to give you an opportunity to provide me with some feedback on how the distance learning structure has been going. None of you have provided me with feedback yet. That doesn't mean you can't. You can type it in the chat if you want to type it in the chat. You can speak up if you want to speak up. I understand now, especially since the cameras are rolling, maybe it's a little high pressure and you're like, oh, I don't want to be on the record, this and that. I totally get it. If you want to send me a Hangouts message just individually and say, Mr. Giorgio, I think this isn't working for me, I want you to do something different, or can you find a different way to explain these, or can you find a different way to use our 30 minutes? Absolutely, I'd be happy to do that. Or if you want to respond positively and say, hey, this is great, then I welcome that as well. All right, but don't be afraid to give me any feedback. I welcome any and all feedback that you can give me, because I'm here for you, so I want to do the best I can to help you out. If you notice over on the sidebar right below where I am, you should notice that I did add the cofunction identities to the list. So we now have our quotient, reciprocal, Pythagorean, and cofunction, which is great. So let's see, what else did I want to add? Oh yeah, after class today, by the way, you will be getting your first assessment of the fourth quarter. How fun! I don't actually know whether to call it an assessment or like a progress assessment. I guess everything's equally weighted. There's not really progress assessments versus summative assessments. So we're going to go with the crazy name that I thought of. We're going to call it a quiz. I know it's radical and revolutionary. We're going to call it a quiz. So you will be receiving your first assessment via email at the end of class. I actually have it scheduled to go out at 1:30 p.m. to you. The reason why 1:30 p.m. is because my A4 class ends at 1:30 p.m., so I wanted to give everybody the same amount of time to actually be able to get the assessment done. I didn't want to give one class an advantage over the other class. So you will have until Sunday night at midnight, that's 11:59 p.m. technically, to get that to me. The reason for the Sunday deadline is so that on Monday I can actually grade it and put your grades in Aspen and give you feedback. If I gave you until the start of next class on Tuesday, then we are already jumping into the next class and it's not graded, and it's like putting everybody behind. I think that Sunday deadline is more than reasonable, and I think this weekly routine of having that graded assignment every week will, number one, get us in a good routine to there's no surprises as to what's expected for pre-calculus, and number two, I think it will give you a good array of grades by the end to say, hey, your actual grade is not based off of like one assignment. It's based off of like a collection of 5 or 6 that are all averaged together. All right. So long-winded introduction aside, let's go ahead and jump in. If anybody has any feedback or questions, though, or you just want to say that you like turtles like Aiden did, then feel free to go ahead and do that. All right. So I have for you today, I don't know if I'm going to get through all of them, I have 10 trig identity problems that I just wanted to grind out with you today and see. Let me just give you some more examples on how we can use our trig identities, which again are right there, to simplify expressions. All right? So let's start with just a couple examples, and we're just going to keep going, and however many we have time for is what we have time for. If you do have any questions, though, while we're going through these, please ask. Don't be afraid to interrupt. Don't feel like it's inconveniencing me or inconveniencing anybody else. Just ask. Start with problem number 1. Okay. Again, I picked 10 problems of varying difficulty. I'm not saying they're going to escalate in difficulty. It's just like, here's 10 random problems. Here we go. How about the cotangent squared of theta times 1 minus the cosine squared of theta? How can we simplify that expression? Well, what I would probably do first is I'd say, 1 minus the cosine squared of theta, that's just a Pythagorean identity, right? It's a manipulation of, can I put my cursor over here? I can. It's the Pythagorean identity, right? It's just a little manipulation of that. So 1 minus cosine squared is the same as sine squared. So I can change this to cotangent squared of theta times sine squared of theta. Now you might notice it would be helpful to write cotangent as cosine over sine. Change everything to sine and cosine. That was the strategy we talked about the other day. So I'm going to rewrite cotangent as cosine squared of theta over sine squared of theta, and then times sine squared of theta. And hopefully you could see by doing that, it shows that sine squared and sine squared would cancel out. And so that whole expression would simplify down to the cosine squared of theta. Okay. Does everybody see how that's done? Just taking the expression and simplifying it as best we can. Let's do another one. Again, if anybody has any questions along the way, interrupt. But otherwise, we're just gonna keep flying through problems. We got the secant of theta times the tangent of theta, all divided by the tangent squared of theta plus 1. My eye is immediately drawn to tangent squared of theta plus 1 because if you look on your Pythagorean identities right here, tangent squared of theta plus 1, it's a Pythagorean identity, that's the same as secant squared. So I have the secant of theta times the tangent of theta, didn't change the numerator, all divided by secant squared of theta. Now take a look, I have secant and secant squared, one of those secants is going to cancel out, so that gives me now tangent of theta divided by secant of theta. There's got to be a way to simplify that, of course there is. Really I'm going to rewrite tangent divided by secant. Hopefully you can see that that's really tangent of theta times 1 over secant of theta. Right? That's the same thing as writing this, and this, right? There's no difference between saying, oh, I'm dividing by secant or I'm multiplying by 1 over secant. It's like if you divide by 2 versus multiply by 1/2. It's the same thing. The reason why I wanted to split it up like this, though, and write it this way is maybe it's a little more clear if you see that, oh, 1 over the secant, well, 1 over the secant is just the cosine. That's our reciprocal identity right here. 1 over the secant is the cosine, so this really becomes tangent of theta times cosine of theta. You could also think of it as you want, instead of splitting it up and writing it like that, that if you take the reciprocal of secant and move it to the top, it would become cosine. And if you take cosine and move it to the bottom, it becomes secant. So that's another way to think about it. And now tangent, again, you can express as sine of theta over cosine of theta, very similar to this problem over here. And then times cosine. The cosines cancel out, and you're left with that whole expression just simplifies down to sine of theta. All right. Again, these are like little puzzles that you have to use your identities, which are below me. Those are your whole tools of identities to try to just simplify this expression as much as you can. Oftentimes, it'll simplify down to just one term. Sometimes you'll get 2 terms. Like if it's simplified to sine, cosine, you couldn't really do anything with that. But most of the time, it just goes down to 1. Let's do another one. How about something like this? What if I had tangent squared of theta times cosecant squared of theta minus 1? All right. Again, you should be looking at your Pythagorean identities, and you notice that, oh, cosecant squared of theta minus 1, that's just some manipulation of this 1 that I have my mouse hovered next to. So that's going to be cotangent of theta, or cotangent squared theta. So this becomes tangent squared theta times cotangent squared theta. Hopefully you notice that tangent and cotangent are reciprocals of each other, so it would kind of cancel out. If you can't see, actually not kind of, it would definitely cancel out. If you can't see that off the top of your head, you could write tangent, or actually you could write cotangent as 1 over tangent. So you could say tangent squared times cotangent. Well, cotangent is just 1 over tangent. And now the tangents cancel out, and you're left with just 1. So that whole expression of tangent squared theta times cosecant squared of theta minus 1 is just equivalent to 1. That's pretty cool. That's cool stuff. Any other question about that? Next problem. Told you, just move it along. Next problem. Okay. How about an expression like this? This one's a little tricky. I got sine of theta times 1 plus sine of theta, all divided by 1 minus cosine squared of theta. Hopefully your eye is immediately drawn to that, which minus 2, minus 1. Well, again, 1 minus cosine squared is a manipulation of Pythagorean identity. We saw that in the first problem. That's the same as sine squared. So I'm going to replace that. I'm going to say this is now sine of theta times 1 plus sine theta. I'm not changing the top yet. All over sine squared. And then minus 1 on the outside there. One of the sines is going to cancel out with that sign. So sine of theta cancels out with one of the sine thetas. This now reduces to, we'll write it over here, as 1 plus the sine of theta on top over the sine of theta on the bottom, minus 1. Very common mistake that a lot of students will do, and please don't do it. A lot of students will go, oh, sine theta crosses out, 1 minus 1 is 0, and they'll call it a day. Very bad. If you had 1 plus x all divided by x, you couldn't just cross the x's out and say that that's equal to 1. That's not how it works. Okay, think of if it were real numbers. If I had 1 plus 5 divided by 5, that's 6 divided by 5. I couldn't just cross out the 5s and say, oh, that's equal to 1. It doesn't work that way. So what we have to do here in order to progress is we have to somehow be able to find a common denominator with this 1. Remember, just a floating 1 is like saying it's 1 over 1. If we can get these two things to have the same denominator, we can then stick the fractions together. So my least common denominator here that I'd like to aim for is sine of theta. In order to do that, I need to just take this and multiply it by sine theta over sine theta. Okay, so I'm going to rewrite this as 1 plus sine theta over sine theta. Didn't change that first part. Now, instead of saying minus 1, I'm going to write that as minus sine of theta divided by itself. Because any number divided by itself is 1 anyway. The advantage of that is now that these have the same denominator, we can go ahead and stick them together. So this is going to become 1 plus sine of theta minus sine of theta, all divided by sine. Right? Essentially, we're just merging these two fractions together. Again, hopefully you see now, you're like, ooh, sine of theta minus sine of theta goes away. I'm left with now 1 over the sine of theta, which we know 1 over the sine of theta. We're going with our reciprocal identities right here. 1 over the sine of theta is cosecant. So that whole expression simplifies down to cosecant. Again, it involves a lot of rules and stuff about your rational functions, about common denominators, about canceling terms out. So hopefully, that's not the confusing part for you. But if it is, please feel free to, again, ask a question, or you can come during my office hours. Just send me a Hangout message. Even tomorrow being Friday, by the way, I'm here like all day at my computer. So not that that's different than the usual. But you can go ahead and just send me a Hangout message and be like, hey, Mr. Giorgio, can you jump in the meet for a minute? I have a question. Sure, I'll be right there. Bam, done. Okay, so please, please, please reach out to me any way you can. Let's move on. How about this problem? I like these problems, by the way, as you can probably tell, because they're like little puzzles. Cosecant squared of theta times tangent squared of theta, and then minus 1. Okay. Kind of a similar thing here, where first of all, I'd want to simplify this term. I'd want to simplify that term because cosecant squared and tangent squared don't look like they have anything in common, really, when you just see them that way. But if I change everything to sine and cosine, maybe it'll become a little more clear. One thing that I do want to point out right away is not to say, oh, tangent squared of theta minus 1, that's one of the Pythagorean identities. First of all, it's not. It looks like it might be, but it's not. Cosecant squared minus 1 is. But this is stuck together. If I had like x times y minus 1, I couldn't just do y minus 1 and ignore the x, right? These are stuck together. So let's simplify this term first. Cosecant is 1 over the sine squared of theta. That's our reciprocal identity right here. And tangent of theta, well, that's sine squared theta over cosine squared theta, and then minus 1. Right? That's our reciprocal identity, or our quotient identity right up there. Okay? Now that I have that, sine squared theta minus over sine squared theta, that's going to cancel out. I'm left with 1 over cosine squared theta minus 1. Hopefully your brain is turning now and you're like, oh, 1 over the cosine, that's just secant. 1 over cosine squared is secant squared. Secant squared of theta minus 1 is now what this expression comes out to be. And that is a Pythagorean identity right here, where you'd see if you move the 1 over to this side, secant squared of theta minus 1 is tangent squared. So it would all reduce down to that. Makes sense, hopefully? Let's keep going. Let's do a cofunction one. We haven't done a cofunction one yet. How about the secant of 90 degrees minus theta minus cosine theta over tangent theta? Okay, how about that? All right. Well, immediately, and again, interrupt if you have a question. Don't feel like I'm just rapid fire without opportunity for questions. Please just ask, please. So hopefully you see right away the cofunction. That immediately stands out to me as this 90 minus theta. I want to just get rid of that and replace that with cosecant of theta. You can see that down here. Secant of 90 minus theta is the same as cosecant. So I'm going to replace this with cosecant of theta minus, I now have cosine of theta over tangent of theta. Okay? What I probably want to do is I probably want to combine these together by using a least common denominator, just like I did with this problem over here, where I needed to combine these together. It's not clear that that is the next step, though. You might be wondering, like, how do you know that you have to do that? That's a great question. You could try manipulating this term and simplifying it and just see if it gets you anywhere. Sometimes it's a matter of, let me just try to see, oh, I could write tan as sine over cosine. To multiply by a fraction, you divide by the reciprocal, or sorry, to divide by a fraction, you multiply by the reciprocal. Does that get me anywhere? It might. It also might not. So in this case, I'm just going to go ahead and try my least common denominator. If it works out, then it works out. And if not, maybe we can backtrack to this step and try something else. So this is really over 1. My least common denominator I'd like to aim for is the tangent of theta, meaning I have to take this and multiply by tangent over tangent. So this expression now comes out to be tangent of theta times cosecant of theta minus cosine of theta all over tangent of theta. Let's see, does this actually help? Well, what I can do is I can go ahead and change these to be sine and cosine. So let's rewrite that as tangent is sine over cosine. Cosecant is 1 over sine. Ooh, look at that. That helps, right? Notice the tangent being sine over cosine is up here. Cosecant being 1 over sine is down here. And then minus this cosine over here, still sticking there. And then over tangent. Well, the sines cancel out, so that's good. I get 1 over cosine minus cosine all over tangent. Let's see. Does that help me at all? Can I really go anywhere from that? Well, 1 over cosine is secant, right? So I have secant of theta over tangent of theta minus cosine over tangent. I kind of split them apart, right? Did you see that? Doing secant minus cosine I don't think helps us. What I could do is I could say, well, tangent is sine over cosine. Let's see, divide by a fraction, multiply by the reciprocal. I'm trying to see like where I can go to actually get help here. Oh, you know what I can do instead of this? Ooh, it just occurred to me. And that's the thing, it's like a puzzle. It just occurred to me. What I could do is I could say, well, tangent is sine over cosine, and then just apply that up here. I could say we have 1 over cosine over sine over cosine, because that's what tangent is, sine over cosine, minus cosine over sine over cosine, right? That's pretty much the split apart that I did there. I just crossed it out. To divide by a fraction, we multiply by the reciprocal. I'm going to do that here. We have cosine theta over sine theta times 1 over cosine theta. Cosines will cancel out. Here I have multiply by the reciprocal, cosine theta, let's see, times cosine over sine. Nothing's going to cancel out there. Oh, but let's see what we get. Here I'm going to get 1 over sine theta. Here I'm going to get cosine square. Oh, we're getting somewhere. We're getting somewhere. Check this out. We're getting somewhere. Combine the fractions. 1 minus cosine squared all over sine. 1 minus cosine squared is sine squared. So that's sine squared over sine. And bam, one of the sines is going to cancel out. That comes out to sine theta. Wow. That was a tough problem. I didn't think that was that many steps. That is a tough problem. Holy cow. That is a major league problem. I wonder if there was an easier way to do it. I mean, maybe if I was at this step and I just changed this to sine over cosine, I wonder if there were easier ways to actually go about that. Not sure. Not sure. If I, up there, let me take a look quickly. If I was up here, right, and I said, well, maybe we had cosecant of theta minus cosine theta over sine over cosine. Then to divide by a fraction, I multiplied by the reciprocal. Suppose I did cosecant theta minus cosine theta times cosine over sine. Oh yeah, I think that this is actually way easier if I went this route instead. Notice I would get here cosecant theta minus cosine squared over sine. Pretty much gets us to where we needed to go in way fewer steps. Let's see, cosecant is 1 over sine, so I really have 1 over sine minus cosine squared over sine. We can squish those together now to make 1 minus cosine squared over sine. It gets us to the same spot. Now we have sine squared over sine, which comes out to be just sine. But that's cool though. The reason I wanted to do that is because you can see multiple avenues to actually get to the same final answer. Some are easier than others. I think I definitely picked a confusing and probably pretty long way to do it. Well, maybe not confusing. Maybe confusing is the wrong word. But a lengthier way to actually go about this. But that's another way to go about it where you could just convert, multiply by the reciprocal. You notice that you get sine in both denominators. You can combine them together and bam, you're done. Okay, but sometimes that's what it's going to take. Sometimes it's just that trial and error to say, hey, I tried this. I mean, it was long, it worked, but there's another way to do it too. You could also try that way. All right, and that I think that's a really cool thing. I'm glad that that happened because that is the case a lot of times when you're working with these trig identity problems. There's just multiple routes that you can take. All right, that being said, let's keep going. We got, what, 5 minutes to go? I'm going to see how many we can get through. Here we go. Fresh sheet of paper. Let's do some more. Maybe something like this. We got cotangent of theta, secant of theta, over cosecant of theta. Okay, let's give this one a shot. Oh, and hopefully, by the way, you took a look at the answer key and the actual practice problems. I really hope those helped. I think those are a big resource, and I tried to be as clear as I could step by step by step, so hopefully that helped you. All right, if I have this, let's see what we can do here. Cotangent, I know, is cosine over sine, so I'm going to simplify the top first. We have cosine theta over sine theta. Secant, I know, is 1 over cosine, so already I see that those are going to cancel out over cosecant. Oh, this one's much faster. Cosines cancel out. I'm left with 1 over sine theta over cosecant of theta. Well, what's 1 over the sine? 1 over the sine is cosecant. So you get cosecant of theta divided by cosecant of theta, and anything divided by itself is equal to 1. So that was a nice quick one, but hopefully you see why that's the case. Change cotangent to cosine over sine. That's our reciprocal, our quotient identity rather, right here. Secant, you know, by the reciprocal identity, is 1 over the cosine. The cosines cancel out. You get 1 over sine in the top. Oh, you're like, well, 1 over sine, reciprocal identity, is cosecant. And now you have cosecant divided by itself, and that just becomes 1. Okay? Like I said, though, it's really just a puzzle. It's really just a puzzle. Let's keep going. How about this? I don't know what this one is. Secant of theta minus sine of 90 degrees minus theta, all divided by secant of theta. Okay. Again, another common mistake a lot of students will make is they'll be tempted to just cross that out. Please don't do that. If you had x minus 5 over x, you can't just cross out the x's, right? We need to be very careful about that. Our eyes should immediately go to the sine of 90 degrees minus theta. I want to replace that immediately. We got secant of theta minus cosine of theta all over secant of theta, right? Hopefully you can see that, right? As soon as I see a cofunction thing, I'm like, ooh, let's replace that right away. Now, I think it's beneficial to probably split up the fraction. I can rewrite this as secant of theta over secant of theta minus cosine theta over secant theta. Here, secant theta over secant theta becomes 1, which is nice. Cosine theta over secant theta, well, that's really cosine over 1 over cosine. To divide by a fraction, let's multiply by the reciprocal. We get 1 minus cosine times cosine, really, over 1, right? Same as multiplying by the reciprocal. If you divide by a fraction, multiply by the reciprocal. Oh, cosine times cosine is cosine squared. And 1 minus cosine squared, bam, sine squared. Pythagorean identity. And there we go. There we go. So it's satisfying. You don't get that same satisfaction. It's a rush. It's an endorphin rush when you get one of these problems. Bam, you're like, wow, it worked. All right, that's what I love to see. Okay, I want to show you just one more. I know we're right at the end, but I want to show you one more because I think this one's important to see. Ready? How about cosine of theta over secant of theta plus sine of theta over cosecant of theta? Very similar to what we just saw over here. I like this problem a lot because it's, again, change this to sine and cosine, change this to sine and cosine. This becomes cosine of theta over 1 over cosine plus sine of theta over 1 over sine. How do you divide by a fraction? You don't cry, you don't panic, you multiply by the reciprocal. This becomes cosine times cosine over 1 plus sine times sine over 1. So what do I get? I get cosine squared, that's cosine times cosine, plus sine squared, that's sine times sine, and cosine squared plus sine squared is our famous Pythagorean identity. That whole expression comes out to 1 as well. Another way you could actually go about that is you could get a common denominator, combine them together, and try to simplify from there. You'd be able to get the exact same thing. I won't show you that just for the sake of time, but try to do it on your own. It's actually a great example. You could say, well, my least common denominator is secant theta cosecant theta, and then just try to combine them together, and you should get that all the other terms cancel out, and you get down to 1 just much in the same way. All right, so we made through 9. That was 9 examples. That was pretty good. Hopefully you can see in doing that, number 10 was actually pretty hard. Hopefully you can see in doing that these really are just like math puzzles. Here below me is your toolbox of stuff that you have to use. These are your tools. This is your toolkit. These are the puzzles that you have to solve. So you have to figure out how can you actually implement these identities to simplify these expressions. That's really the challenge that is presented to you in a unit like this. So, that being said, I appreciate your attention and focus today. I really appreciate that. The assessment email will be coming to you in about an hour and a half from now. It'll be at 1:30 p.m. You have until 11:59 p.m. on Sunday night to get that to me. Just like before, you can take a picture of your work and email it to me. It's 4 problems, 4 identity problems, kind of like these. So that should be more than enough time to get that done. That's why I don't really want to accept any late assessments, because that's an ample amount of time, I think, to do that. All right? If you have any questions or concerns, feel free to reach out. Do not hesitate. Other than that, I hope you have a fantastic day. I hope you have a great lunch. I hope you have a great weekend. And best of luck. See ya.